Hello students, in this video let us see the third and fourth example based on midpoint theorem. The third example says ABCD is a rectangle and PQ, R and S are midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rhombus. So the figure is not given to you. You have to draw the figure here. So it is said that ABCD is a rectangle and PQRS are midpoints on the sides AP, BC, CD and DA. So these are the midpoints. You can see there is a quadrilateral which is formed with the midpoints or joining the midpoints of these rectangle. Now you have to show that the quadrilateral PQRS is a rhombus. So you know that to show that a quadrilateral is a rhombus, first you have to show it is a parallelogram. Then you have to show that all sides are equal. So if you show these two properties, then you know that the given quadrilateral is a rhombus. First let us see what is given to us. It is given that ABCD is a rectangle. So you know the opposite sides are equal as well as parallel. So AB will be equal to CD and AD is equal to BC. And each of these angles is 90 degrees. Or it is sufficient if you say one of the angles is 90 degrees. Now we have to show that PQRS is a rhombus. So you know, since midpoint is given to you, you have to use midpoint theorem. Now to use midpoint theorem, you need triangles in it, right? So how will you get the triangles? You will get the triangles if you join the diagonals of the rectangle. So if you join the diagonals, then you will get two triangles. So let us join AC and BD. So we have joined AC and BD and we have got some triangles here. Okay. So first let us take the triangle ABC. So now in triangle ABC, if you see here, P is the midpoint of the side AB and Q is the midpoint of the side BC. Okay. So now you know that by midpoint theorem, if you join these two midpoints of these sides AB and BC, then this line segment PQ is parallel to AC and PQ is half of AC, right? So by midpoint theorem, we can say that PQ is parallel to AC and PQ is half of AC. So let us number this equation as 1. Now similarly, let us take the triangle ADC. So in triangle ADC, we have S as the midpoint of AD and R is the midpoint of DC. So now if we join this R, S and R, then this line segment SR will be parallel to AC and SR will be half of AC, again by midpoint theorem. Okay, so by midpoint theorem, SR is parallel to AC and also SR is half of AC. So number this equation as 2. So from 1 and 2, PQ is parallel to AC and PQ is parallel to SR. So we can say, PQ is parallel to AC and SR is parallel to AC. So we can say PQ is parallel to SR. And PQ is half of AC and SR is also half of AC. So PQ is equal to SR. So we have got PQ is parallel to SR and PQ is equal to SR, correct? So we know a theorem which says in quadrilateral, or if you have a quadrilateral in which one pair of opposite sides is equal and parallel to each other, then it is a parallelogram. So in this quadrilateral, we can say PQRS is a parallelogram. Now since PQRS is a parallelogram, you know opposite sides are parallel as well as equal, correct? So we already know that PQ is parallel to SR and it is equal. Also, there is another pair of opposite sides which are parallel and equal, which is that it is QR is parallel to PS and it will be equal, correct? So PS is parallel to QR and they are equal. Okay. Now let us take the other. Now we have proved that it is a parallelogram. Now what we have to prove is all sides are equal. So now let us take the other two triangles, that is triangle BDC. Okay, first we'll take the triangle BCD or BDC so that we can concentrate on these two sides. Now we have finished with these two sides. Now let us see these two sides. So in triangle BCD, you know Q is the midpoint of BC and R is the midpoint of DC, correct? So we can say by midpoint theorem that QR is parallel to BD and QR is half of BD. So let us number this equation as 4. Now let us take the next triangle, fourth triangle, that is triangle, which is the fourth triangle, triangle ABD. So in triangle ABD, we have S is the midpoint of AD and P is the midpoint of AB, correct? So PS will be parallel to DB by midpoint theorem and also PS will be half of BD. So let us number this equation as 5. Now from equation 4 and equation 5, we can say QR is parallel to PS, correct? QR is parallel to PS and also QR will be equal to PS. QR is equal to PS because both are equal to half of BD. Now you know property of a rectangle which says the diagonals of the rectangle are equal. So AC will be equal to BD, correct? Since the diagonals of a rectangle are equal, AC is equal to BD. So now here we have got QR equal to PC, which is equal to half of BD. So QR is equal to PS will be equal to half of AC because AC is equal to BD. And we also know that PQ is equal to SR and both are equal to half of AC, correct? So from these two equations we can say PQ is equal to SR will be equal to QR equal to PS. So in this way we have seen that all the sides are equal. So we can say PQRS is a rhombus. Now let us see the fourth example. The fourth example says ABCD is a trapezium in which AB is parallel to DC. Also, BD is a diagonal and E is the midpoint of the side AD. A line is drawn through E, okay, through E, this point E, we have drawn a line which is parallel to AB. And this line E, drawn through E, intersects BC at the point F. You have to show that F is the midpoint of BC. The figure is already given to you. Now, it is said that this is a trapezium in which AB is parallel to DC and BD is your diagonal. E is the midpoint of AD. Now it is said that there is a line which is drawn through the point midpoint E, okay, and it is the passing through the side BC at point, or it intersects the side BC at point F. Now you have to show that F is the midpoint of BC. Again, since midpoint is involved here, you know you have to use midpoint theorem or converse of midpoint theorem. It has something to do with midpoints. Now, it is said that E is the midpoint of the side AD, and you know that this EF which is there, it is said that this line which is drawn through the point E is parallel to AB and E is the end, one of the midpoint is given to you. So by converse of midpoint theorem, you know that if you draw a line or if you have a midpoint of one of the side, okay, and you draw a line passing through this midpoint such that it is parallel to the other side, then this line will intersect the third side at a point which is a midpoint of this side. You know that, right? So let us say that this line EF intersects the side DB at point G. Correct? Now let us take the triangle ABD. So in triangle ABD, you have EF which is parallel to AB and E is the midpoint of AD. Then by converse of midpoint theorem, you know that G will be the midpoint of the side DB. Correct? G is the midpoint of the side DB. Now, we have to show F is the midpoint of side BC. So, you know, you have to, again, you can use converse of midpoint theorem, and for that we need to take this triangle, right? Because F, this side or this point is on this particular triangle. So let us take this triangle BCD. For that we have to know that whether this line is parallel to this line. Now in the question it is given that EF which is there is parallel to AB, correct? It is given EF is parallel to AB, and also it is given that AB is parallel to CD since it is a trapezium. So EF is parallel to AB and AB is parallel to CD, then EF will be parallel to CD, right? So EF is parallel to AB and AB is parallel to CD, then EF is parallel to CD because two lines which are parallel to the same line are parallel to each other. So now we know that this line is parallel to this line, correct? And so now we can take this triangle. So let us take the triangle BCD. So in triangle BCD, we know that EF is parallel to CD. So this line is parallel to CD, and GF, so if EF is parallel to CD, I can also say GF is parallel to CD, correct? Because this is a part of this line. So in other words, it is GF is parallel to CD and G is the midpoint of the side BD. So by converse of midpoint theorem, I can say F is the midpoint of the side BC. So F is the midpoint of the side BC.